deemed university and the first private engineering college of Haryana, established in 1995. Also, he is the president of Institution Innovation Council and ARIIA nodal in charge of university. Adding feather in his cap, he is an innovation ambassador and having own faculty startups. He holds and other responsibilities as a dean, faculty of engineering and technology, and member of board of studies and DRC committee for research. He completed his PhD in computer engineering in the year 2012, Master of Technology, BITS Pilani in the year 1999 to 2001, and Bachelor of Engineering at Mumbai University in the year 1994 to 1998 with honors. He published his papers in international journals and presented papers in international conference. More than 140 papers are published. He also edited 6 textbooks. He organized 10 international conferences. He has 22 years of rich experience in teaching, research, and industry managing technical institutions, serving in all capacities, including head of department, professor, controller of examination, dean academic affairs, principal, etc. Played leading role in accreditation, NAAC, NBA certification, including 5 years of industrial research experience. He was a great editor in various journals like IGI Global Database and Web of Science journals, Journal of Computational and Theoretical Nanoscience, International Journal of Engineering and Technology, Advances in Mathematics, Scientific Journal, Bentham Sciences on Telemedicine, and in special issues on creating smart world using blockchain, Internet of Things, and data science applications. He was an editor-in-chief of various international journals, convener and member of various international conference, committees, and publications. Chairman of ICC and ICC-MIT RTCA-IT held in the year 2019. Sir, we are pleased to welcome you.
Thank you, ma'am. Now request Avnish Sharma sir to occupy this journey. Thank you.
Thank you for giving the introduction. I hope my voice is audible.
Yes,
And
sir,
I request you to kindly allow me the share screen option.
Sir, you have been given, sir, please.
I hope the screen is visible to all the participants.
Yes, sir.
Thank you very much. I am very happy that the GRG Polytechnic is conducting such a nice AICT, IST sponsored refresher program for the participants, as well as the theme of this particular faculty development program is also very much interesting. It is focused on smart city planning and management. And we have enough scope for this particular theme to do some more kind of learning as well do some kind of research, because India needs more smart cities. India needs more smart city planning. India needs the smart city management, and for that, the current technology, that is artificial intelligence, blockchain, and Internet of Things, amalgamation of systems can really help in order to do the smart city planning and management. So I would like to interact with some of the participants in this particular session, that you are from the different parts of the country, from India. Do you think that your city is a smart city, or it is on a direction for the smart city? Or what thing you see that smart in your city, whether it is having a smart railway station, whether it is having a smart traffic system, whether it is having a smart, you can say, like a smart city management system, or smart kind of, any kind of smart system which attracts the citizen of that particular city or that particular state to prefer that we should have a house in this particular city, or we should migrate to this particular city for the purpose of living, for the purpose of education, or for anything else. So if you have any answers, then please try to put your answers either in the chat box, or you can also speak to me that yes, this particular thing draws your attention that this particular city is a smart city, or it has a smart planning, or it has a smart management. So I pause for 1 minute, and if you have any answer, then please try to answer so that we can continue this particular session in an interactive way. Or even if you are not living in a smart city, but you have knowledge that a particular city is a smart city in India, okay, specifically in India I'm talking about, okay, we should not talk about the developed countries, okay, because developed countries already have these particular technologies in use. They are using this particular technology, but we have a wider scope to use this particular technologies in our country for making the city smart. So if in your mind you have an idea, or if you have knowledge of a particular city that it is a smart city, then please try to put in a chat box, okay, so that we can make a more discussion on that direction. If the participants remain active, if the participants respond, then it will be a more interactive session. Otherwise, also I want to take this particular session because already, pardon me.
May I respond to your question?
Yes, please.
Okay, Dr. Avinash, I am Renu from Bangalore. So my answer would be, at present, we cannot say any particular city to be holistically smart, though different cities are having certain features of a smart city. Now, in the developed world, technically enabled and IoT enabled cities are only called smart city. But at the stage where India is, different cities have to have first basic infrastructure, good transport connectivity, and good governance. Then they would gradually become smart. As of now, if we see, there are certain features in some cities. So some examples I can think of is, for example, Indore in Madhya Pradesh has a smart waste management system, smart bus transport, or for an example, Bhubaneswar in Orissa, it is a smart in terms of planning of the city, development of the city. Chandigarh is having good planning in terms of how the urban development is done there, because it's not random development, but it is done in a planned way. Now gradually other cities like Surat are also evolving, but we cannot say that one particular city is completely smart as of now.
Thank you for giving the answer, and I totally agree with you, because currently whatever smartness is there, okay, it is according to the development authority. For example, if you talk about Chandigarh, and if you talk about any other cities which you have given the examples, even from Madhya Pradesh, also from other cities also. So right now, the development authority who are working in any other city, okay, they are not very much aware of that, how technology can transform, as well as the citizens who are living in that particular city have a single expectation, okay, from only the authority, only from the government, that this kind of smartness they need, this kind of smartness they desire. But what kind of role that the researchers, or as the technocrats basically, we can play in order to help our government, or in order to help the ministries, that how the technologies can make them helpful to make the smart city to plan and manage. So this is the important thing, and this is the important task, or this is the important thing which is very much important. And for that, we as the educators, okay, we need to understand that what are these technologies basically, and how these technologies can play a very vital role, a significant role, in order to make any city smart and to manage that particular smart city. So today's session is going to be on the 4 different things, which is very much important. I have divided this particular session into 4 different parts. First is that we should know what is AI, what is artificial intelligence. What we should also know what is blockchain. Okay. then we should know what is IoT systems, that is Internet of Things system. And we are not talking about pure IoT system, we have to think about the industrial IoT systems. Because whenever we are talking about IoT systems, then we have to interface it with the industrial requirements. Because in every city, we see that there are industry, okay, there are industries operating in every city, okay, there everything is seen in a form of industry. So that is an industrial IoT system, because when we are talking about a smart city, okay, then we can also that what is the pollution control of that particular city, or how the industries are monitored in that particular city. Okay, so that kind of system we have to understand that what is industrial IoT systems, and then we have to understand that what is smart city planning and then the management. So these things I am going to cover in today's session. So moving on to my slide. This is the content I am going to take. First is what is artificial intelligence, then what is blockchain, what is Internet of Things, and what is smart city planning and management. So you say what is AI? AI is basically artificial intelligence. It is a full form of AI. But in order to understand AI, that is artificial intelligence, we can understand a very simple definition, and that means the smart machines that are capable of performing the smart task. So gradually we are transforming everything into a form of machines. That means we are eliminating the humans and we are replacing the human beings with the smart machines. The reason that the smart machines can perform the smart task, because humans have a tendency to commit the errors. That is the reason we are focusing on artificial intelligence. So this is how the learning process in artificial intelligence have evolved. It started in the year 1950, and at that time we had only the AI concepts. After that, machine learning and deep learning has come into the features. In 1916, we have seen the machine learning, and in 1970s, we have seen the deep learning. And nowadays, now all the applications are the combination of the AI, machine learning, and deep learning concepts. And we have lot and lot algorithms, we have lot and lot features available to do the planning with the help of AI, machine learning, and deep learning. So this is the machine learning process, how it works. It is the result of general artificial intelligence. It involves developing the machines that can deliver results better than the human beings. So machine learning generally builds the algorithm that can receive the input data, and it can use the statistical analysis to predict an output while updating the outputs as new data becomes available. So in the case of a machine learning, we have an automated system, and with the help of artificial intelligence, we are training the machines, and those particular machines are called as the machine learned machines, and the machine learned algorithm enable the computers to learn the data. So this is the total machine learning applications which are available, and there are more number of machine learning applications. These are only not the limited. For example, we can see the image recognition systems, we have the medical diagnosis system, we have the market trading system, we have the automatic language translation systems, we have the fraud detection systems, we have the self-driving car systems. So these are the some of the typical machine learning applications which are existing and which are used. Based on the three different types of algorithm, that is unsupervised machine learning algorithm, supervised machine learning algorithm, and the reinforcement learning algorithm, we also have the different type of features, different type of applications, that is clustering, dimensionality reduction, classification, regression. And these particular methods, okay, they have their own different type of applications. That is, if you want to design any recommender systems, if you want to do any digital marketing, or we want to do any targeted marketing type of applications, then we can use the clustering approach. Then if we want to do the big data visualization work, if you want to do some kind of feature extraction work, then we can do the dimension reduction kind of. Then if you want to classify the things, that is, if you want to classify the customers based on their characteristics, then the customer retention kind of work, image classification kind of work, identity fraud detection kind of work, this can be done with the help of a classification technique. If you want to do any kind of forecasting, that is weather forecasting, if you want to do market forecasting, okay, then that can be, what can be done based on the regression type of algorithm. So I have classified the different machine algorithms in the form of supervised learning, machine learning, unsupervised machine learning, and the reinforcement learning types of algorithm. So these are the supervised machine learning types of algorithm. In this, we have a simple function y is equal to fx, where y is the output and x is the input. So an algorithm to learn the mapping function from input x to the output y is called as a supervised machine learning algorithm. And the goal is to approximate the mapping function so that when we have a new input data x, that we can predict the output variable y for particular data. So in this type of application, the data is labeled and the algorithms learn to predict the output from the input data. So this is how unsupervised machine learning works. We have an input raw data and we have a supervised machine learning mechanism. In that we have a training data sets, and on the basis of that particular training data sets, we obtain the desired data with the help of algorithm, and that is processed in the supervised machine learning algorithm, and we get the desired output data. This is how supervised machine learning works. So we have a raw data, and then particular data is cleaned on the basis of a supervised machine learning model, and we get the data with the help of the evaluation model. So you see that how the data is split into the training data sets, and the training model is applied, and on basis of that we get the data. This is the unsupervised machine learning model. We have the input data and there is no corresponding output variable available. So the goal of unsupervised learning is to model the underlying structure or distribution of the data in order to learn more about the data. The basic difference in the supervised and unsupervised machine learning is that in supervised machine learning the data is labeled, but in case of unsupervised machine learning the data is unlabeled and the algorithms learn to derive the structure from the input data. So how unsupervised machine learning works? We have the input data and we have the untrained output. That is, we have the unnamed output and there is no training data sets. So there is no labeled data and we have the specific algorithm for unsupervised machine learning and then we get the output. This is the unsupervised machine learning process which is shown here. It has a simple difference only that in case of a supervised machine learning, we have the labeled data. In case of unsupervised learning, we have the unlabeled data. Now, in order to understand deep learning is a subfield of machine learning that is concerned with the algorithms inspired by the brain structure and the functions known as the artificial neural network. So, a computer model can be taught using deep learning to run classification actions using pictures, text, or sound as a input. So we have an input and on the basis of the feature extraction and the classification method, we can say that the image of the particular input is of what type. So here we can say whether it is a parrot image or whether it is a non-parrot image. This is the output of the deep learning method. So how do deep learning algorithm learn? This particular type of algorithm uses neural network to find the association between the set of inputs and outputs. So a neural network is composed of input, hidden and output layer. There are three types of layer working in a neural network. You have to remember there are three types of network layers working in a neural network. One is called the input layer, one is called the hidden layer, and one is called the output layer. The role of input layer is that it takes the numerical representation of data. For example, if we have image, so image is not in a form of a numerical data, so it has to be converted into the pixels. And similarly, the output layer also gives the results in a form of numbers. And that numbers can be again reconverted into a form of the data, and that is called as the prediction. So information is passed between the network layer through the function as shown in the above figure. So in the deep learning algorithms, we have two types of inputs. One is called the weight and one is called the bias function. And these are the two parameters which are tuned essential to learn the process of the deep learning algorithm. How deep learning processes work, deep learning algorithm work. You can understand this particular thing with the help of model. We have to understand the problem, we have to identify the data, we have to select the deep learning algorithm, and we have to train the model, and then we have to test the model. So why we have to use artificial intelligence for place of smart city and smart, smart planning? Let us talk an example of a traffic system. All of us have experienced a traffic system. In a traffic system, what we see that when the traffic lights are blinking for 90 seconds, 120 seconds, or sometimes 30 seconds, depending on that whether that particular traffic is a big traffic or it is a small traffic. But sometimes we see that number of vehicles available in a particular direction are less, but still the other vehicles have to wait in order to get their chance to run. So this is a traditional traffic system, but with the help of deep learning process, if you can train our traffic system lights, that if at a particular time the traffic in a particular direction is very less, in that case this can turn on the lights of the other traffic system, and it can allow the traffic to go more smoothly as compared to a traditional traffic system. So we have to replace the person as a traffic person with the help of a smart traffic light management system. So these kind of algorithms can be used in order to train the data for a smart traffic light management system. But for that, what we need the real data. We need, if we are having the real data sets, then with the help of that, we can train our model in order to make a better decisions that when to turn off the light in a particular direction or when to turn off the light indicator. So for that, we need to understand many things. We need to recognize the image. We need to recognize the speech. We need to also understand the language. We also understand the language. Okay. That means whether there is a kind of a specific noise, okay, or what is happening in that particular direction. So one is called the image recognition system, one is called a speech recognition system, and another is called the natural language processing system. So these particular combinations, okay, helps us to analyze many kinds of data, and with the basis of that, we can do many kind of process. For example, if we want to make the smart healthcare management system, in that case, we can do the drug discovery and disease detection in the case of healthcare. We can make the robotics and self-driving car system. Okay, that can also help the smart traffic, and it can help the cars to drive smoothly for the accident-free kind of traffic. Okay, so these particular things can help. The next one is the deep learning use cases. We are having the three types of deep learning use cases. One is the ANN, one is the CNN, one is the RNN. So ANN stands for artificial neural network, CNN stands for convolution neural network, RNN stands for recurrent neural network. Applications of artificial neural network is the tabular data sets and in the classification of the prediction problem and the regression of the prediction problems. Applications of the convolution neural network is for the purpose of image data and for the classification prediction problems and for the regression prediction problems and for the object detection problems. The recurrent neural network has the applications in the text data, in the speech data, in the classification prediction problems, in the regression prediction problems, like this. So artificial neural network, basically they are more suitable for the classification prediction problems where inputs are assigned a class or a label, and suitable for the regression prediction problems where a real value quantity is predicted on the given set of inputs, and when the data is often provided in the form of a tabular format. So according to the applications which we are designing for any kind of a smart system, then we have to choose that whether we are going to use the artificial neural network, or we are going to use the convolution neural network, or whether we are going to use the recurrent neural network. This is how artificial neural network works basically. We have the inputs, we have the weights, On the basis of that, we calculate the net input function, and that net input function is combined with the activation function to get the output. The recurrent neural network basically has many features. That is, it is designed for the visual applications where images are decomposed into a series of patches and the sequences, with example of sequence prediction problems. We have the different type of relationships, that is 1:many, 1:1, and 1:many. 1:many means the observation as input back to a sequence with multiple steps as an output. In many-to-one, we have sequence with multiple steps as input back to the class or quantity prediction. In many-to-many, we have sequence of multiple steps as input back to a sequence with the multiple steps as output. So these are the various options where we can apply the recurrent neural network. This is how the recurrent neural network works. This is the convolution neural network example. It is designed to map the images data to the output variable. It allows the model to learn position and scale in the varying structure in data, which is important when work is going to be done with the help of images. It works well with the data that has a spatial relationship. A spatial relationship, that means if there is a traffic management system, that means there is a crowd of the vehicles, that is called a spatial data, and that is called a spatial relationship. That is a dynamic relationship. Convolution neural network is a traditional two-dimensional, or it's a field or a matrix that can be also be changed with the help of one-dimensional. It is designed to recognize the visual patterns directly from pixel images with the help of the minimal pre-processing. This is the convolution neural network working, and this is the comparison that how we can compare the machine learning with the help of deep learning on certain parameters. The parameters could be data dependencies parameter, hardware dependencies parameter, feature engineering parameter, execution time parameter, and interpretability parameter. So in case of the data dependencies, machine learning has excellent performance on small and medium data sets. But in case of data dependencies, deep learning has excellent performance on big data sets. In case of hardware dependencies, machine learning work on low-end machines. That means with the help of low-end machines, we can implement the machine learning. But for implementing the deep learning, we require the GPUs. That means we cannot specifically use the CPUs for implementation of machine learning. We use the GPU. We need the high-end processors. For feature engineering, we need to understand the features that represent the data. And for deep learning, we need to understand the best feature that represent the data. Execution time for machine learning is few minutes to hours. That means within few hours, we can obtain the desired result. But for obtaining the results in case of a deep learning, we need up to weeks time. So neural network needs to compute a significant number of weights. So one of the drawback of deep learning is that we need the high computing power and we need the high time. For integrity issues, in case of machine learning, some algorithms are easy to interpret. That is, they work on the logistics, decision tree types of mechanism, but deep learning, it is not possible. These are the regression algorithms which are helpful in simple linear regression, multivariate linear regression, polynomial regression, support vector regression, and in case of a continuous value. So there are two types of linear algorithms. One is a simple linear regression and one is a multivariate linear regression. In case of a simple linear regression, we have two variables. One is the output variable and one is the input variable. And the output variable, that is y, is directly proportional to the input variable. For example, if we see a simple line equation, y is equal to mx plus b. So this is an example of a linear regression example. Suppose if you want to find out the weight of a person depending on a height, or if you want to predict that what will be the height of a person depending on the weight, in this case we can use the simple linear regression algorithm. So simple linear regression algorithm focuses on finding the relationship between two continuous variables. The variables which helps in prediction is the independent variable, whereas the variable which is dependent predicted is called as a dependent variable. And the goal is to find the line that fits the data best and the overall error is low. This is the multivariate linear regression example. It uses the multiple variables to predict the outcome of the dependent variable. And it helps the extension of the simple linear regression. It can have more than one variables, that is M1, M2, M3, X4 like that, and X1, X2, X3 like that. So if there are more number of variables, then we can use the multivariate linear regression. This is the clustering. Clustering basically helps to group the different types of things in a form of a cluster. That means some images, some kind of different type of images, some kind of type, like typical or some kind of similar kind of image that can be grouped in a form of a cluster, and that clustering determines the internal grouping, that is with the help of unlabeled data. So this is how the machine learning and deep learning can be used to collect the data and to form the data sets. Now, after collecting the data and the data sets, what is more important, the data should not be modified. That means data remains predicted. We are concerned about the security of the data. Now, in order to make our data more secure, in order to ensure that the data is not modified, we have to use the concept of blockchain. So now is the time to understand what is blockchain. So what is blockchain? A blockchain is a continuously growing list of records called as the blocks, which are linked and secured using cryptography. This is the definition given by Wikipedia. And in order to understand the blockchain, we need to understand that there is a kind of protocol which is working in order to connect all the blocks, and that particular protocol is called the consensus protocol. In order to analyze the data, we need to perform some kind of mining process. In order to secure our data, we need to do some kind of hashing activity or some kind of cryptography activity we have to do. So that is called the hashing cryptography work. Then we need to ensure that the data is not modifiable, and that is the beauty of blockchain, because the record is stored in a immutable ledgers. That means the record once stored cannot be modified. Even if the data is tampered, then all the blocks get the information about that, so that it can be easily identified that the block is tampered. Where it started, that means when did the blockchain started? As we already know that deep learning started in 1960s, 1970s, but blockchain started late, and it started in the year 2008 basically. Blockchain technology was first introduced in a white paper entitled by Satoshi Nakamoto. Satoshi Nakamoto is just a name. We don't know whether it is the name of a person, whether it is the name of an organization, or whether it is a group of organizations. Sometimes it is called that Satoshi Nakamoto is a group of organizations where SA is for Samsung, Toshi is for Toshiba, okay, Naka, then Motorola, Nokia, like that. So these are the group of organizations which have worked together, and then they have published this particular white paper describing that how a Bitcoin technology works, a peer-to-peer electronic cash system. So in this particular paper, they have described blockchain that there is a digital signatures concept, there is a proof of work consensus mechanism concept, then there is a public history of transactions concept, identify that which are the nodes involved. So this is the things which are given and described in this particular white paper. Now, immutable ledger concept we have to understand, because immutable ledger is one of the beautiful property of the blockchain. In the traditional ledger system, we have some kind of record, but the records can be mutable. Mutable means they can be changed by some undisclosed authority. And once the records are changed, then the authenticity of the record is lost. So the record becomes of no use. In that case, we use the blockchain concept, because in blockchain we have the immutable ledgers. The records once created cannot be modified. So this is the beauty of the blockchain, that is immutable ledgers. This is a blockchain history and overview. Already told you that blockchain started in 2008. It was informed in a Satoshi Nakamoto released Bitcoin white paper, and this has told the industry that the blockchains have been popularized, and current blockchains which are available in a form of Ethereum framework, okay, and Hyperledger project solutions by Intel, as well as some numerous other including examples are available. So these are the things which are already available. Now this is the growth of blockchain technology, how blockchain has grown. The blockchain has started with Bitcoin concept in 2008, then blockchain has given the options to replace the financial system with the help of cryptocurrencies. Now also some countries are working on cryptocurrencies, so that is they are having a smart financial management system. So smart financial management system can also help a particular country or a particular state, okay, in order to do the work in a smart way. So we can have some kind of system, okay, which is blockchain enabled. Then in 2013, some ideas started to emerge that they suggested using of blockchain in other areas and in the cryptocurrencies. Nowadays, some countries, some states, some countries are also states are also using some kind of concept of blockchain-enabled voting system, or the land management record are used by the blockchain systems. So it impacts the the industry, financial growth, media, law, and arts, etc. And by 2025, we can see that the blockchain technology is expected to become mature with a high number of user inputs. So this is the origin of the blockchain, the Bitcoin payment system. So in this, we have the blockchain created using the Bitcoin system. Bitcoin as the first decentralized digital currency, as it does not rely on central government authority. And using like in a blockchain, there is a upper limitations that we can have around 21 million of Bitcoin. So Bitcoins, they are not increasing. Okay, day by day, Bitcoins always decrease because more and more Bitcoins are mined by the miners, and that is the reason. Whenever we are going to apply the blockchain concept in any kind of system, so we have a beauty of the blockchain that we have the system which can control with the help of security functions called as cryptography and the other immutable concepts which are already available with the help of blockchain. So how blockchain is going to work? We have to store all the digital records in a digital form, and that will be called the storage for the digital record. Then the blockchain can help to exchange the digital assets with the help of tokens. And then we can write down some kind of smart contracts on the basis of which our blockchain is going to work. So there are some ground rules, some kind of terms and conditions which are available, and we have to follow all the concepts which are there in a blockchain technology for designing the smart system. So these are the existing frameworks which are available for the blockchain. That is, Ethereum blockchain is the most popular blockchain for developing the smart contracts. Ethereum is a public. It will also works as a private blockchain with the built-in Turing complete language to allow writing any smart contracts. Ethereum is a virtual machine, that is EVM, which can execute scripts using international network of public nodes. And Ether is another cryptocurrency which is available in a blockchain. So post-quantum blockchain concepts are also available. Post-quantum blockchain concepts are the classical cryptography algorithms that is used in that blockchain technology. Then we can manage the quantum attacks with the help of these things. And quantum attacks are the great thieves, which are classic cryptography algorithm. And research is shown that the study of the suitability of the quantum immune cryptography can help us to minimize the digital signature applications. Cryptography algorithm works with the help of three functions. One is the key generation algorithm, one is the encryption algorithm, and one is the decryption algorithm. So these are the algorithms which are used for generating the different encryption function and the decryption functions. This is how the hashing part of works in case of a blockchain. We have a pre-image resistance system, we have a second pre-image system, and we have a collision resistance system. With the help of that, we can digest the message of an arbitrary length to generate a hash value of a fixed length. These are the various algorithms which works in a blockchain. Typical algorithm which works in a blockchain is called SHA-256 algorithm. There are also other algorithms and other encryption algorithms which works together in order to make blockchain system more proof. This is how we can understand the hashing algorithm. Any PDF file can be generated in a hashing code, okay, with the help of SH256 algorithm. It is a 64-bit algorithm. There are 5 requirements for the hashing algorithm. The first requirement, it should be one way, it should be deterministic, it requires fast confirmation, then there is avalanche effect, and the most withstand collisions are applicable. Symmetric key and cryptography and asymmetric key cryptography are the two things which are existing here. The assumptions which are done in case of a symmetric key cryptography is that the same key is to be used for both encryption and decryption. The two communication algorithm shared secret key which somehow has been distributed to them, or the use of a key distribution center. The problems with the symmetric key cryptography is that one is the key distribution and one is the digital signatures. Key distribution is how to have secure communication in general without having a trust or a key distribution system with your key. Digital signature is the problem that how to verify a message that comes to interact from the claim sender. Public key cryptography is having the 6 ingredient, that is the plain text, encryption algorithm, public and private keys, ciphertext, and the decryption algorithm. This is how the public key cryptography works, that the sender has to give the key to the sender, and the sender uses the public key to encrypt the plain text from plain text to the ciphertext. So the plain text is converted to ciphertext with the help of the encryption algorithm. In the step 3, sender gives the ciphertext to you, and then the sender decrypts, the receiver decrypts the ciphertext again with the help of decryption to the plain text. These are the cryptocurrency concepts which are there in front of you. The technology behind Bitcoin is obviously the blockchain. So the thing that Bitcoin is an electronic digital currency system, a network of computers that keeps track of the Bitcoin payments, and it adds them to an ever-growing list of all Bitcoin payments that have been made, called as the Bitcoin blockchain. The file that contains data about all the Bitcoin transactions is called as a ledger. So a Bitcoin value is created through transaction processing, referred as a mining, which is performed by distributed processes called as nodes of the peer-to-peer network. This is the difference between digital signatures, that how the message has been passed from one person to the another person. This part, that is electric curve cryptography, is also the part of public key crypto systems. Every user has a public and private key. So public key is used for encryption, signature verification, and private key is used for decryption and signature verification. So the ECC, that is electric curve cryptography, are used as an extension to other current crypto systems. These are the smart contracts. That means if you want to write any smart contract for any smart application, so we have to understand that what is a smart contract. A smart contract is an executable code that runs on the blockchain to facilitate and execute and enforce the agreement between the untrusted parties without the involvement of a third trusted party. So the smart contracts can be called as to the transactions. Smart contracts are irreversible and immutable. These are the blockchain attacks. Attacks associated with the mathematical technique used for creating the blockchain frauds, stale blocks, other blockchain type of attack. Attacks associated with the peer-to-peer architecture used in the blockchain system, example, selfish mining, then conscious delay, DDoS attack, domain name system attacks, fork after fidelity attacks are also called as this type of attacks. Attacks associated with the application context that uses the blockchain technology, that is ingestion, double spending, okay, wallet theft are the kind of attacks. Okay, so in order to recall your knowledge, okay, whatever I have described about the blockchain and the concepts, okay, first of all, we need to understand that what is the difference between a blockchain and a hyperledger. Hyperledger is a combination of a blockchain. Blockchain is simply a concept. So blockchain can be used in multiple fields such as businesses, government, healthcare, etc. While hyperledger is primarily used for enterprise-based solutions. Whenever we talk about public blockchain, it refers to the uses of blockchain on the internet, and the hyperledger-based blockchain on the solutions meant for using on the internet and the internet within the organization. So hyperledger can be implemented in the organization, but blockchain can be implemented without the organization that it can be implemented publicly. So blockchain is a public concept, but hyperledger is a private concept because it can be implemented in a organization. Then what is a blockchain technology and what is meant of a Merkle tree? Merkle tree is one of the important concepts in order to implement the cryptography, in order to implement the security features. We need to understand Merkle tree. Merkle tree is a type of a data structure that is used to verify a block. It is in a form of a binary tree containing cryptographic hashes of each block. A Merkle tree is structured similarly to a binary tree where each leaf node is a hash of a block of transaction data, and each non-leaf node is a hash of a sleep node. So the Merkle tree root or Merkle hash root is the final hash root of all the transaction hashes. It encompasses all the transactions that are underlying all the non-leaf nodes. Then if you want to apply some kind of algorithm, we can apply SHO-256, we can apply reverse Shamir Edelman, that is RSA algorithm, we can apply DES algorithm, we can apply Blowfish algorithm for implementing the cryptographic algorithms. Then what is the meaning of distributed ledger and what is the meaning of traditional ledger? So a blockchain distributed ledger is highly transparent as compared to the traditional ledger. Blockchain distributed ledgers are irreversible, information registered or distributed ledger cannot be modified, whereas traditional ledger is reversible. A distributed ledger is more secure, it uses cryptography and every transaction hashed and recorded, whereas in a traditional ledger security can be compromised. So these are the various things about the blockchain and distributed ledger and the concepts. So how can we identify a block in a blockchain? The first block is always
Sir? Sir? Hello. Sir? Avinash Sharma, sir? Sir? Sir, Avinash Sharma, sir? No audio.
sorry, it got unmuted it got unmuted by some mistake. I hope now the voice is audible.
Yes, sir. Yes, sir. Now it is okay, sir. Please.
Thank you. So these are the various applications we can apply the blockchain smart contracts. We can apply the blockchain concepts in transportations. We can apply the blockchain smart contracts in protecting the copyright content. We can apply the blockchain smart contract in insurance. We can apply in the employment contract. So these are the various applications of the blockchain. So you see that how many types of frameworks are existing in case of a blockchain. Ethereum networks are existing. Okay. Now, since the time is less, so I'm going to focus on the IoT part. Okay, these are the various concepts and mechanisms proof of work, proof of stake. Okay, these are the various consensus mechanisms. I'm going to focus now on the IoT part because IoT is also one of the important part because we have to design the AI-based blockchain systems for the IoT system. That is, I was talking about the industrial IoT systems. Okay. So what is IoT? IoT is basically a smart device which supports the internet connectivity, and they are able to connect with the other devices over the internet and grant more access to the users of managing the devices as part of their need. So there are different types of IoT project. Okay, that kind of IoT projects depends on that what kind of experience we have, what kind of existing model we have, then how we can analyze, how we can control, and how we can build. So these are the typical things which are very much important for designing any IoT system. First, we need the experience. We need the experience about that particular system, about that particular traditional system. Then we need to have a specific model that how we are going to frame the things, and then we have to analyze, we have to control and build the IoT system. These are the building blocks of the IoT product system. There are the different types of IoT hardware which are available. For example, you can see that there are Arduino kind of IoT hardware. Okay, then Arduino boards are available. Then Raspberry Pi kind of IoT hardware, like that is available. Then we have a specific communication channel. Then we have either the local server or whether we have a cloud server. So ThingWorks is a type of a cloud server which is already available. Okay. So these things are integrated together to form a building block for IoT product. These are the applications of the Internet of Things. One is in the form of the B2C consumers for designing the smart home, smart appliances, okay, for caring of the elderly people. So these are the applications of the IoT. We can also apply IoT in case of industry and smart farming. That is, in case of the smart manufacturing, in case of the smart agricultures. Then we can apply the IoT in infrastructure also for smart city, for smart energy and utilities, for environment monitoring process. Then we can apply the IoT in case of the commercial sector for the medical and healthcare. We can apply for transportation. We can apply for building automation processes. So these are the typical applications where IoT can be used, and already some of the industries are already using the IoT concepts. Okay, we go to the hospitals. Okay, in that particular hospital, we see the sensors. With the help of sensors, the health of the patients is monitored. So that is called as the robot-based system for monitoring the health of a system. That means the nursing facilities are automated. In some cases, we see that the large machines, the complex machines are controlled by the robots. That is the IoT-based machines. That is called as the applications in the industry and farming. Sometimes we see that the farmers, okay, are given some kind of additional support in order to do the smart farming or in order to do the smart agriculture. Okay, so that is called the industrial farming applications. These are the existing industry the benefits already available from IoT. Okay, with the help of IoT, we can have all these things in a smart way. We already have some kind of variables, that is smart watches are available. Okay, smart watches helps us to monitor the health of a particular person. That is how many steps the person has moved in a particular day. What is the current heart rate of a particular person? Then what is the current blood pressure rate? What is the current other crucial health parameters? So these things are really helpful in order to have a smart system. Okay, then we also have some kind of indicators in the industry that can determine that how much energy is produced. Okay, then for city management, okay, for monitoring the security services smartly. Okay, IoT is used. In case of retail, also IoT we are using. We can also use IoT in case of an automotive system in order to avoid the accidents. Okay, you can see that there are smart cars available. They can sense the objects from a specific kilometer. so that we can avoid the accident. Also, some kind of existing systems are available where we can identify the threats well in advance in case of dark light system, or we can see that whether some kind of objects are available in a fog. Okay, now in a winter season, okay, there are lots of accidents happening due to the fog, so that can be also identified. So these are the existing benefits are already available with the help of Internet of Things system. This is the future of IoT. This is the future of IoT. We can say that the IoT can have future in the daily life applications for making the life of the people smart. And then we can have the application of IoT in case of a traffic system. Then we can apply IoT in the industries for making more and more type of production. And we can apply the IoT in the logistics systems, that is supply chain management. We can apply IoT in retailing. We can apply the IoT in the human resource system for resource planning and power control systems in industries. So IoT can have applications almost everywhere. This is the future of IoT. This is the future of IoT with the help of blockchain, with the help of artificial intelligence, with the blockchain, with artificial intelligence, with the help of virtual reality, with the help of automation, with the help of augmented reality systems. We can have a smart system. We can have a smart home. So you can see that with blockchain technology, artificial intelligence, AR, that is augmented reality, virtual reality, automation, we have a smart home. These are the type of IoT sensors which we will be needing for designing any IoT-based system. So we need the temperature sensors, we need the gas sensors, we need the image sensors, we need the pressure sensors, we need the proximity sensors. These are the type of IoT sensors which will be really helpful to design any kind of typical smart system using the IoT. These are the different type of IoT sensors. I am going to explain all the sensors. There is a LED sensor called the white LED sensors. There is a rotation sensor. There is a capacitive touch sensor, flame sensor, which is used for the fire equipment, rotary infrared system. Okay. Then passive buzzers, knock sensors, vibration sensors are there. Okay. Then buzzer sensors are there. Gas sensors are there. Gas sensors are typically used to sense the typical combination of the gas. Okay, then joystick sensor. So every sensor, analog temperature sensor, every sensor has its own applications. So depending on what kind of applications you are making, you can choose your sensors. These are the various components of the IoT system, okay, which can be helpful for designing any IoT systems. These are the IoT processors. You see there are different types of IoT processors. Arduino boards are available. Then Raspberry Pi systems are available. Raspberry Pi boards are available. So these boards can really help in order to design the IoT process system. This is how we are having a smart truck, that is a smart vehicle, with the help of a IoT system. In this particular system, we can identify that what is the pressure in a tire of a particular truck, so that we can avoid the punctures, we can avoid the breakdown of this particular truck. We can have a sensor on the top of truck that is connected through the internet, and that can provide the live information to the admin dashboard in order to provide that what is the location of the truck, whether the truck is in a safe position or not. And this can also help that by what time the material can be shipped. That is, it can help in a smart supply chain management system. And this is how the practical example of IoT is in front of you. That means with the help of IoT-based sensors, we can have a smart truck which can help us in a smart supply chain management. Then these are the elements of IoT, that is elements of Internet of Things. Okay, we need the cloud data storage, we need the scheduler, we need the request destination, we need the request presentation, we need the service delivery and utility manager, and the sensor middleware. The industrial real scenario of IoT is that at the BTech level, many people are there, but they do not really have any knowledge of the IoT. So there is a mass number of crowd which are there, but they are having little knowledge or almost no knowledge about the IoT. And then if you go up to the university level, that is up to the level of MITs or IITs, then good university has some type of knowledge about the IoTs. But only few people have the knowledge about the sensors, IoT, and also that thing. And that is the knowledge is limited in the IoTs and MITs. These are the IoT devices for the purposes, that is ESP8266 and Raspberry Pi. Okay. Raspberry Pi is a system which is applicable, and it works on the Linux system, which is an open source system, and it gives advancement to work in a GUI mode. It can be used to interface monitor, mouse, keyboard. It is much like a mini processor system. You can integrate monitor, you can integrate mouse, you can integrate the keyboard, Ethernet, camera, etc. That means it can be put in a LAN system. Then Arduino this is the pin diagram of Arduino. You can see that Arduino is also another type of IoT preprocessor. It is represented, image shows that the complete system architecture of Arduino, GPIO plays great role in microcontroller as it is used to interface the potential peripherals like communication devices, sensors, other controllers, etc. GPIO's pin can be configured according to use as it can generate output. It can write the digital and analog signals, or it can accept input, and it can read any kind of digital and analog signals. These are the communication processes, that how with the help of satellites we can control the cars with the help of our systems. This is the communication process. Basically, we have the 5 layers in the communication process of any IoT system. We have a physical layer, we have a data link layer, we have a network layer, we have a transport layer and application layer. At the application layer, we have the different protocols working. Those protocols are called as the HTTP protocol, MQTT protocol, AMQP protocol, XMPP protocol. At transport layer, we have the transport control protocol and the user datagram protocol. At network layer, we have the different protocols: IP version 6, IP version 6, IP version 4, ICMP, 6LoWPAN. These are the network layer protocols which are working. And then the data link layer, physical layer, we have the different protocols which are working. So in the communication process, we have to send the data and events to the network to some destinations. How to implement, or we have to IoT application implement. Okay, we have different business use cases, we have different problem statements, and on the basis of that, we can design the different IoT applications for the purpose of implementation. These are the business use cases, and with the help of business use cases, we can reduce the time to repair, we can save the operating cost, we can know the location of assets. Okay, so these are the various benefits which are available with the help of the business use cases in order to implement the IoT-based system. This is the problem statements where we can use the IoT-based system. That means if we have too much money, okay, in order to manage the logistics, then if we need the optimized version, if you want optimized version of the traffic system, if you want to obtain more customer satisfaction, then if you want to insight into the location of the data, in that case also we can use this particular kind of systems. So these are the applications, okay, where we can have the smart connected product system. We can first of all, we have to automate, then we have to optimize, then we need to control, and then we need to monitor. So this is the IoT smart connected product system. IoT devices basically are smart devices which have the support for internet connectivity and are able to interact with the other devices over internet and grant remote access to a user for managing the devices as per their need. So basically, the IoT product is in the form of smart connected product. That means we essentially need the internet connectivity, because only with the help of internet we can have a smart connected product. And so IoT devices are basically the smart devices which have support for the internet connectivity, and then only they are able to interact with other devices over the internet and grant remote access to a user for managing the devices as per their need. This is one of the very much important definition about the IoT. Okay, there are different types of system available in our home. That means we have a smart machine, we have a smart systems, or we have smart air conditioning systems, but they are not the part of a smart home. Okay, they are only the smart AC, they are the smart washing machine, they are the smart system, they are not the IoT based system. Systems which can work according to the internet, okay, then only we can say that it is a IoT smart connected product. Now, this is the last and important part about the smart city planning and management. That after the amalgamation of the different technology, that is artificial intelligence, blockchain, and IoT, how we can do the smart city planning and management. So, first of all, let us understand that what is the smart city development. The smart cities uses the data and technology to create efficiencies, improve sustainability, create economic development, and enhance the quality of life factors for people living and working in the city. So it means that the city has a smarter energy infrastructure. So in a smart city, we can have everything in a form of a smartness. That is, we can have a smart traffic system, we can have a smart solar system, that means that can generate energy on demand. We have on demand driven traffic control system. We have on demand battery research and production facility system. We have on demand traffic lights, we have on demand street lights, that whenever suppose the temperature is going below down, suppose if there is a darkness during the winter session, suppose at that particular time, so the lamps which are available, the street lights which are available should automatically turn on. And suppose if there is enough brightness, then those particular smart, the street lights or those kind of lamps should automatically turn on. So this is the meaning of a smart traffic system, or a smart system in which we can understand that how the energy is optimized in a form of usage. So wherever we are able to save the energy, okay, in a form of a traffic system, or in case of a smart light system, so that is called the energy conservation. So we are able to save the energy. Then at the same time, suppose if you are having a traffic system, so in a traffic system also, if you are able to generate the smooth traffic, then if you are able to avoid the accidents, if you are able to control the traffic, then it also becomes a smart traffic system. Then, as one of the participants, I think so, usually told that waste management system. Waste management system is also the part of a smart city that can be helped with the help of sensors, gas sensors. Suppose if we get a kind of a bad smell from a different part of city, so that immediately the development authority or the people who are managing the waste, okay, in a particular city get an immediate alarm that this particular part of the city, or this particular place in a particular city is smelling badly because of some kind of bad waste, so that they can immediately arrange to uplift it. Okay, so that the things which are now running under the clean city concept, or the cleanliness drive at India or at a country level. Okay, these things can also work as a part of smart cities. For that, we need to deploy enough type of sensors, and we need to connect all the places with the help of a blockchain technology, so that the immediate information is available to the controlling authority and they can act on that. For that, we need to write the smart contracts. How to write the smart contracts? What are the components of smart contract that already I have described earlier. So, a smart city is a framework predominantly composed of information and communication technology, that is ICT, to develop, deploy, and promote sustainable development practices to address growing urbanization challenges. As we see that there are more and more number of urban cities available. Okay, there are more and more cities which are very much polluted because of the industry pollution, and due to the different type of pollutions like noise pollution. So many things are available. So there, everywhere there is a need that how we can make that particular city as a smart city, and we can do the management of that particular city. These are the blockchain-based IoT use. So blockchain enables network participants to exchange the data with a high degree of reliability and transparency without the need for a centralized administrator. So we do not use any kind of centralized administrator. Okay, with the help of a blockchain, we can make it in a distributed environment. Okay, it can be monitored in a distributed way. Cities have a variety of stakeholders, and the exchange of data among stakeholders is essential for a highly convenient urban services. When the smart cities uses IoT devices such as connected sensors, lights, and meters to collect and analyze the data. The cities, they use this data to improve the infrastructure, public utilities and services, and more. So these are the use of a blockchain-based IoT systems. Then use of IoT and artificial intelligence. Smart city make use of artificial intelligence, then the cloud-based services and Internet of Things devices such as connected sensors, then lights and meters to collect and analyze the data. So the cities then use this data to improve the infrastructure, public utilities, services, and many more things. So this is how we can integrate the IoT with the help of artificial intelligence. So first of all, we need to have the sufficient data. Data set is very, very important in order to use the IoT with the artificial intelligence. If we do not have the real data for any kind of AI system, that we cannot integrate IoT with the help of artificial intelligence. First of all, we need to collect the data, and after analyzing the data through the artificial intelligence, different type of algorithm which I already explained, that is ANN, artificial neural network, convolutional neural network, recurrent neural network. You have to first analyze that which type of data is there, whether it is a spatial data, whether it is a any type of specific data, that is, it is data which is to be analyzed on a multivariate linear regression algorithm or a linear regression algorithm, then only we can classify this particular data, or we can cluster the data, and then we can apply and the IoT on that. This is one of the slide which has explained you that IoT based AI systems, okay, can help us in traffic management. It can help in public safety. It can help in gas and water leak detection systems. It can help in smart healthcare. It can help in managing water smoothly. It can manage in monitoring the quality of water. It can also help in education. Okay, that is monitoring the schools. Basically, there are government schools. Okay, it can monitor that how the children are safe in a school or not, or whether the education is happening properly or not, whether the education place or whether the specific place are hygienic or not. That is also very much important. So that can be monitored with the smart systems based on IoT. Okay, then we can do the smart city light system. We can check it. We can see the pollution of the air. We can monitor the parking systems in a particular city or a particular place, whether the parking has been done properly or not. Okay, then we can see that whether the building constructions is proper or not, whether some kind of illegal buildings or illegal construction is happening in a city. That can be monitored easily, so that the government can take immediate steps behind such kind of illegal constructions. We can also make our environment smart in a particular city with the help of monitoring parameters. We can do the waste management, that is also possible. We can manage the open data, we can manage the social data, suppose if something is put wrongly on a social media, whether it is trending in a viral mode, okay, which can create some kind of bad impressions, or it can create unnecessary type of violence in case of some emergency situations. That kind of things can be also monitored on open data with the help of the AI systems. So finally, I'm going to conclude on my presentation today. These are the benefits of AI and IoT. The first benefit is that it can reduce the energy cost, carbon emissions with the artificial intelligence. There is ability that the city can be detected in the various inefficient systems. So the data can be optimized and the cost can be reduced. Then it can improve the air quality, it can improve the humidity, it can control the pollution, it can control the humidity, then it can detect that what is the presence of chemicals, what is the pressure of air, and all the things can be monitored in order to ensure the better health of the persons. Then it can reduce the traffic congestions. That is, smart traffic lights can be responded with help of congestion flows. IoT systems can be implemented in cars, and that can sync up to the electric charging points to reduce searching time, and real-time maps can be identified on the parking spots. Then optimization can be done on the waste management. That is, smart garbage bins can signal density levels to waste management companies, thereby improving and providing the removal services as needed. So these are the benefits of artificial and IoT. The last part of today's presentation is that how we can do the management part. That is, the smart city management is the productive utilization of advanced projects and services through information and communication technology, ICT, to provide various applications and strategies for the better operations of the city. So this is how AI is going to work with IoT. AI-enabled IoT creates intelligent machines that simulate the smart behavior and supports in decision making with little or no human interference. So while IoT deals with the devices interacting using the internet, so AI makes the devices learn from their data and experience. So the role of IoT is to sense through the help of internet, but the AI helps to learn from the previous and the past experiences. So the IoT and AI when merged together, so they can think in a more smarter way, and that is the reason the applications of AI and with IoT is continuously increasing. So how blockchain empowers smart cities? It can empower the smart cities by providing access to larger volumes of data from within and outside the organization. So blockchain helps artificial intelligence to scale up to provide more actionable insights, and it can manage the data usage and data models by sharing and creating a trustworthy and transparent data economic systems. These are the benefits. These are the benefits of AI and blockchain. AI helps in blockchain learning through a highly thoughtful, intelligent, and interactive manner with the ideal training data required by the algorithm. Therefore, it is clear that the top AI blockchain projects can provide exceptional revolutionary outcomes in their own communities. So the better levels of transparency alongside possibilities for gaining insights into the minds of machines with the blockchain can help in developing public trust. The most important reason that comes forward, it is about selecting the AI blockchain projects is the ability to of AI management blockchains. So with this benefits of blockchain, it is very much clear from our presentation that both the technologies, that is artificial intelligence, blockchain, and IoT, together they can revolutionize they can revolutionize the management of the smart cities. Okay, so these things will really help for developing the smart cities around us. Okay, so with this I conclude my presentation, and now I keep 10 minutes open for any queries, any questions from the participant side. If they want to ask me any questions on any of the technique, that is artificial intelligence, blockchain, okay, IoT, on any specific questions, then the platform is open for the participants. They can put their questions in the chat box, or the organizers can allow them to unmute to ask their questions, so that I will be able to utilize my remaining time for answering the specific doubt or queries or questions. Any of the professor, any of the faculty from the participant side, if you have a specific question, you can ask up your questions. You can put your questions in chat box. I'm able to see the chat box. If any questions are available, I'll be able to read and I'll be able to answer.
Thank you, Professor Dr. G. Avinash Sharma, sir. Now it's a time for queries. I request the professors to interact with the sir. Our guest is available.
Thank you. I am open for any queries to be asked by any participants.
Dear professors, please raise your questions. Professor
excuse me,
Renuka,
sir.
please. Please.
Hello, sir.
Yes, yes,
Sir, please
Sundaran,
continue.
I can hear you. Please speak.
Sir, good evening, sir.
Good evening.
Sir, if there is any relation between this blockchain and cryptocurrency, sir?
Blockchain and cryptocurrency, yes, definitely there is a relationship. Okay. Already I
sir.
that blockchain is a concept which has been seen first in a form of a Bitcoin. 2008 when the Bitcoin was announced. Okay, so Bitcoin was a real application of a blockchain, and Bitcoin is nothing but a cryptocurrency. Okay, so everyone asked that whether Bitcoin is a blockchain. Then answer is no. Bitcoin is the application of a blockchain. Cryptocurrency is the application of blockchain. So likewise, you can see many type of applications of blockchain. Cryptocurrency is not only the application of blockchain. Okay, blockchain is a concept. Blockchain is a concept in which we can say that whenever the records are created, okay, they are stored in a decentralized manner. That is not in a centralized manner. First of all, that means no single person is having a control of any particular record. So records are stored in a decentralized mode. That is the first beauty of the blockchain. Then whenever a record is stored, then it is stored in a form of a ledger. That means a copy of that particular record is stored everywhere. Suppose I am dealing with you, okay, and you are dealing with someone else. Any transaction is happening, so our record is recorded in a form of a ledger. And if anyone try to modify that particular record, that is not possible because immutability is one of the concept of a blockchain, and that is the reason if we get some kind of record which are not modifiable, okay, then it will automatically remove the corruption. Okay, corruption generally happens in some kind of departments or somewhere where the records are changed back end. We are not aware that whether the record is changed or not because we do not have any control, and because of that corruption increases.
Okay, sir. Thank you. Thank you, sir.
Okay, so that is the reason the whole concept, the whole idea is that how we can merge blockchain concepts, okay, with the other concepts of deep learning and machine learning in order to store the data which is learned by the machines in a proper way with the help of blockchain, and then we can integrate IoT sensors, and with the help of that we can identify or we can make some kind of system which can really, that is in true sense, it can say that it is a smart system. A smart system cannot be simply on based of IoT. A smart system can be totally simply it cannot be based on AI applications because each and everything is having its drawback. Okay, because if you are talking about any kind of AI system, so okay, yes, we can have a good data, we can have a trained data, we can have accurate data, but what will happen if someone changes that particular data? So we need to ensure its security. That is the reason we are using blockchain, because with the help of blockchain we can ensure that the data is not changed. That is, data remains immutable. Okay, and with the help of IoT we are connecting all these things with the help of internet. Okay, with the help of different sensors we are trying to get the immediate real data from the surrounding environment. That particular data we are integrating, and with the help of that amalgamation of all these technologies we are trying to develop a smart system.
Okay, sir. Thank you. Thank you, sir. Thank you.
Thank you very much.
Thank you, sir.
Professor Renu, please. Renu ma'am, please. Professor Renu, you are not audible, please. Okay, madam, no issues. Please put your question in the chat box.
Question in chat box. If your audio is not working, we will try to read your question and we will answer the question also.
Any more questions from the audience?
Any other audience, if you are having any audio issues, then you can put your question in chat box. I'll try to answer your question, don't worry. And I thanks all the participants for listening it carefully, the presentation. Yeah, the question from you is, could you highlight some standards relating to smart cities and IoT? So there are various standards available. Right now, industries are planning on this particular standard. There is currently the industry 4.0. Okay, this is the current standard on which we are developing some kind of things. Okay, the government officers along with the intellectual persons are working on industry 4.0 concepts. So these are the current standards on which we are working. I hope the answer is clear.
Thank you, Renu ma'am.
Industry 4.0 is the current standard.
Now I request our Vijay Menaka ma'am, lecturer of IC department, to say few words about our resource person. Thank you, ma'am. Please.
Okay, ma'am.
Okay, ma'am. Thank you, ma'am. Sir, your session is very excellent, sir. You explained very well about machine learning, deep learning, artificial neural network, recurrent neural network, convolution neural network, blockchain, hyperledger, smart contractor and its application, benefits of AI and IoT. Explain how these are very helpful to build a smart city. Very wonderful session, sir. Thank you, sir. Thank you very much, sir.
Thank you very much, madam. Thank you very much. Thank you. Thank you all the participants for listening carefully. Thank you very much.
Thank you, professors. On behalf of self, IC department and JRG Polytechnic College, we are highly thankful to Professor Avinash Sharma sir, who has accepted our invitation. And I should say thanks to Somashekaran sir, who has referred sir's name. And we have a very highly knowledge and renowned person in this AI and blockchain and applications of IoT. Thank you so much, sir. And now I request all the professors to fill the feedback link, which is posted in the chat box before leaving the session.
And can I leave the session now?
Please, sir, please. Thank you so much, sir. Thank you very much.
And can I leave the session now?
Yes, sir. Yes, sir, please. Yes, sir, please. Dear professors, please fill the feedback link before leaving the session. As I mentioned earlier, the question bank, the feedback link is having some questions also regarding both the sessions in the morning and afternoon. Kindly answer the questions. The questions are very simple and you are able to answer it by listening the sessions. And before 5:30, please share with me. I believe that, and I hope you all will cooperate with me. I'm also one of your sailing in same boat. We are all sailing. One of your colleague. Kindly consider my request and share the feedback link filled form before 5:30. And tomorrow we will join the session before 9:15. And I would like to request you that all the speakers' contact details are available in your session schedule. If you have any doubts, you can directly contact with them. Their mail IDs and contact numbers I have mentioned in the session schedule. Kindly go through it. Please apologize. We are not posting the feedback link in the chat box. I mean, in the WhatsApp group. And we know that some professors fill the form. I mean, copy the form in the feedback link, the chat in the also.